All right. We are going to start our lightning talk. So if you've not experienced a lightning talk, it is a 5-minute blitz of a talk. First, we have Cory here. Cory Goldfuss is a senior manager at VMware. Cory has been a lover of tech from an early age, first exploring and learning on a Commodore 128. Woo! Yeah. A career IT veteran. He has worked in multiple industries across the private and public sectors and currently leads an SRE team at VMware supporting FedRAMP authorized SaaS offerings. Cory, come on up here, man.
Woo! Thank you. All right, thank you for the introduction. So it was several years ago at VMware. We were getting ready for a FedRAMP moderate audit, and we were doing some CIS compliance scans. Specifically, we were doing CIS benchmark against Windows Server 2012. Out of the laundry list of changes that need to be made, the one I found most stupid was 19.1.3, turn on the screensaver. It didn't really, to me, it didn't do much with the hundreds of virtual machines, someone walking by, hijacking my VM. Needless to say, I wanted to get back to real work, so I just checked the box. Enabled the screensaver. The compliance scan passed, life went on. So today I want to challenge all of us to go beyond checking the box. When you're involved in an audit or implementing compliance controls, be sure to ask questions, approach everything with a DevOps mindset, weigh the impact to your service. Is anything going to break? Is it going to increase costs? Be sure to have a continuous dialogue with the security team, compliance teams, and when possible, go farther. At VMware, one example of us going farther is when we had to implement Department of Defense certification across our security tool stack. So we went to the DoD website, cyber.mil. You can get a STIG for various applications. STIG is just an acronym, Security Technical Implementation Guide. In this case, we wanted to get Splunk. So on the website, we could download the STIG for Splunk. Similarly, VMware products, if you go to core.vmware.com/stigs, you can find many of these similar hardening components for the VMware product family. Once that's downloaded, you can't just view it. You need to get the Dista STIG viewer. You can see here we've got several STIG IDs. Each one is going to be a various part of the application that we can change the configuration on. So our team, we developed an Ansible role called STIG Splunk. Mike Schimmel developed this. It'll either check to see that we're compliant or it'll actually harden our application. So in our case, we broke each STIG ID into a separate task within the Ansible role. You can see here, turning on the login banner, forcing FIPS compliance. If we drill into one of these, you can see we're doing a recursive chown on the Splunk home directory, just making sure that it's owned by the Splunk user, the Splunk group. It sets a great foundation moving forward. As new STIGs are released, new versions of Splunk, we can easily update these YAML files and ensure that we're still compliant. When it comes to audits, you don't want to end up like this person and manually take screenshots and gather inventory sitting in the office all day. So some easy wins there. If you're maybe going through a SOC 2 audit and they request a server sample from your inventory and they want you to show who the local administrators are, what services are running. In this case, we can do some PowerShell. Read in the CSV file, do invoke command, connect to each server, pull the local admins, write all this to a log file. Here's an example of a file that an auditor would receive. This can all be zipped up, hashed, and provided to them as an artifact. Similarly, if we want to do some screenshots, here's an example of Python. Similar process, we're going to loop through the list of servers, SSH to each server, maybe look at a running service, configuration file on that service, and then we actually call PyAutoGUI to generate a screenshot. So we have an artifact of server name, date and timestamp. Here is the zoomed in example. The auditor would actually see the entire desktop so they can see the commands that were executed, what server we were on, and then the image to the right is going to be the date and timestamp, proving that that's when we gathered this artifact. So hopefully this encourages you to get some easy wins on automation when it comes to compliance. And then here's a quick WTF table for some of the acronyms that you've heard me say today. Thank you.
All right. Thank you, Cory, for kicking us off. I have not thought of invoke command in a long time. That's some PowerShell goodness there for you. All right, next up we have David Vossel. David Vossel is a principal software engineer at Red Hat. David contributes to open source project KubeVirt, a virtual API for Kubernetes. All right, David, come on up. There you go.
All right, my name is David Vossel. I work at this place called Red Hat, and I spent a lot of time working on open source software. And for the past few years, I've been working on this project called KubeVirt. And KubeVirt is kind of this backwards idea in a lot of ways. So what we did is we took a look at a Kubernetes cluster, which is designed to manage container workloads, and we tried to imagine what would it look like if we ran virtual machines instead. And the result is we ended up kind of turning Kubernetes into this equivalent of a infrastructure as a service provider. So we made it possible to run virtual machines in Kubernetes using similar patterns that you might use to manage virtual machines in something like AWS's EC2 or something like that. But why would we want to do this? This is kind of going in the opposite direction that the industry's headed today. So everyone's transitioning to containers, but we're not. So why are we doing this? The use cases, they're kind of niche. Typical use cases involve things like virtual desktops. So somebody wants to launch a bunch of Windows virtual machines, and they want to hand them out as digital workstations for employees. We have some telco edge use cases, other more legacy stuff and exotic stuff. But at the end of the day, this is the same stuff that you're using VMware for, or maybe OpenStack. But I don't really care about any of this. I'm just kind of using all these practical use cases to weasel my way into my ultimate goal here. But maybe before I get into that, I want to talk a little bit about what Kubernetes is. And Kubernetes, if you're not familiar with it, it's a lot of things, but I think it's easily described as a digital cluster manager for containers. And that's probably a simplification, but we're going to run with that one for now. What Kubernetes is not it's not an operating system. It's just a bunch of distributed control plane components that have to run on top of an operating system. And that operating system has to run on physical or virtual hardware somewhere. So where does Kubernetes run? We commonly see it in the cloud in places like AWS, Azure, GCP, all the normal places. Then we see it on premise as well. So VMware, we're going to see it on OpenStack and just plain old bare metal servers as well. But the point is, Kubernetes has to run an operating system, has to run on hardware somewhere. So winding this back a little bit to my ultimate goal, if Kubernetes has to run somewhere, and that somewhere can be a virtual machine, and with KubeVirt, we can run virtual machines in Kubernetes, then does that mean we can run Kubernetes on top of Kubernetes? And yeah, of course, we can. And it works really well. And it's actually kind of surprising because I'm not the only one who's been thinking about this. So we started a project called Cluster API Provider KubeVirt that aims to make this pretty dead simple. You just start with some cluster YAML, so just a manifest, declaratively post that to your Kubernetes cluster, and then magically you're going to get a new nested Kubernetes cluster within that. And it happens fast, in like under 5 minutes, maybe less, depending on how you've cached your images. And we've seen a lot of use cases emerge out of this. They're kind of surprising. And I think multi-tenancy might be one of the strongest use cases. So today, if I have an application, I need to run on Kubernetes. I have to get admin to give me access to that, which is kind of a pain because inevitably I'm going to need more access over time. And as you grant me more and more access, I'm going to take down the entire cluster because I'm an idiot. But if you have the ability to spin up clusters within clusters, an admin can just give me my very own cluster to ruin, which they seem to like a lot more. But the point I'm trying to make here is I think that the cluster boundary is one of the strongest and best forms of multi-tenancy. So the ability to quickly spin up clusters on demand actually makes that a reality for us. So everyone can have their own cluster, and it's practical. Other use cases, we're seeing some huge companies use this in their CI pipelines. So what they want to do is they want to take an application, test it on a specific version of Kubernetes. So they take a cluster YAML, they throw it into their CI pipeline, which spins up a Kubernetes cluster. They test their app on it, and they tear the whole thing down again, and then they're done. It's just a ephemeral cluster just for their CI needs. And I think one of the more obvious, maybe just practical use cases is cost savings. So we've kind of squashed the virtual machine management platform out of the picture. It's just Kubernetes all the way down. So people can save on licensing costs, and they also save on just operational expenses because they only need people who know how to run and operate Kubernetes, and that's it. Whew. All right, I said a lot of words really quickly. That's it. You can find more information on our GitHub for cluster API provider Kubevert, and I'm on Slack as well. And thank you.
That was impressive. That was a really good Pechakucha. If you don't know, if you've never tried to do a Pechakucha, doing what he just did right there is really difficult, having the auto advance of slides. All right, we're going to do something a little bit different now, actually. We had a talk submission from somebody in Ethiopia. So Henrik, he's calling in from Ethiopia. He wanted to be a chemist, a physicist, an astronaut, and even a fictional character like Harry Potter and Sherlock Holmes. But currently, he's an undergraduate student majoring in computer science. He's a software engineer intern at Queen Games. It's the first 3D company 3D game company in Ethiopia, and a research apprentice at Amygdala AI. He's also a regional manager of Code Day, Google DSC lead, and contributor to CNCF, and many other open source projects. Henrik, we're so happy to have you here. Take it away.
All right, thank you so much. Yeah, so as you might probably saw in the website, I wrote a ton of stuff. This is my first time being a speaker, so I don't have any experience, so I just wrote a bunch of stuff there. I don't know if that's necessary or not. So I'm gonna talk about hackathons and open source community. So I am Henok, and I'm a fourth-year undergraduate student studying computer science. I am research intern at Machine Intelligence Research Labs, software engineering intern at Kubernetes Games, and I've been into 50+ hackathons, and I have won over 11 of them. And I'm gonna speak about hackathons. All right. I don't know why this is happening. Okay. Okay. So what is a hackathon? So a hack could mean a lot of things, you know. It could be a programming language developed by Meta. As you might probably know, it's a possible tag in a comment in a programming that could be a hack, or it could be a domain name, or the most obvious one, hack into a computer, or a network-related keyword, right? But what is a hackathon? So a hackathon is an elegant but effective solution to a computing problem. This is a vague definition, right? So a hackathon is an event where you try to solve something, right? So it's a gathering of individuals who work together to solve a specific problem. So you go to a hackathon, and what you expect is you'll meet a bunch of people, maybe new friends, new setting, and then you probably learn so many new things. I learned a lot of technologies. I heard Docker for the first time in a hackathon, and I used it in just 24 hours of learning, right? So that is a hackathon, and there will be some specific themes or domains, or there's something that you try to hack. So what is the relation of a hackathon and open source community? So the flexibility of a hackathon and the creativity can help open source communities. So what I'm proposing is that open source communities, you know, there's like code contribution and a lot of contributions to these open source communities mostly happen on Slack and GitHub, right? But what if we make those issues, like GitHub issues, into a hackathon? Because people can use different approaches. They can be creative, and then they can do a lot of things, right? Because in a hackathon, you have a lot of flexibility to be creative, and everyone is free from traditional development restrictions, and they can do a lot of things. So they can do that to open source community. So let's say there's a DevOps related company, and they have a bunch of issues on GitHub, and they want people to solve them. So they will pick like some maybe swags or prizes for people who solve them, and then they can make it a hackathon, and then they basically can do that. So contributions will be enjoyable and useful, because there will be freedom of that. Also, you can make deadlines and timestamps for it, so people cannot, can do it in a shorter time. So this will make, open source communities, the members, everyone, a sense of belonging and a lot of, fun into the community. That's it. I hope I did well. Thank you. And the last one is saying thank you in my native language, Amharic. Thank you again.
Thank you, Henrik. Hey, can you hear me?
Yeah, I can hear you. Yeah.
Thank you so much for coming. I was just curious, what time is it there in Ethiopia?
It's now 9 p.m.,
Okay.
9:30.
Yep, thanks so much for joining us. I hope that you heard the applause just then.
Yeah.
Thanks so much, and glad to have you in Chattanooga at DevOps Days.
Yeah, thank you. Thank you so much. Thank you.
All right. Everybody give it up for Henrik one more time. All right, our last lightning round speaker is Ashley Parks, who is a senior DevOps engineer at Toyota Connected in North America. She started out her career in tech as a software developer in languages including C# and Java. Come on up. While at Toyota Connected, she transitioned into DevOps while working on telematics service platform. And take it away.
Hello?
That one is on, yes.
Cool. Yes, hello. So my name is Ashley Parks. I've been at Toyota Connected for about 4 years. So you've probably heard of Toyota, but what is Toyota Connected? It's a small technology company that was founded in 2016 when Toyota moved their headquarters from California to Dallas. We have about 200 full-time employees. And just to give you an idea of the scale of the services that we create and how they affect the world, just in 2021, Toyota sold about 2.5-ish million vehicles only in the US. So everything we do has an impact. So what do? I work on this thing called Safety Connect, which you've probably heard of something called OnStar. It's basically like that, but for Toyota. So what that means is if the vehicle gets in a car, we're able to connect the vehicle occupant with a call center agent, have them talk to the person, see if they need emergency assistance help, we'll send an ambulance to them. Our call center agent will know exactly where they are. If they fell off a cliff, we'll know where they are if they're off the cliff, something like that. We also have features such as an SOS button that's in the vehicle where they can request assistance that way if they're not in a crash and get them roadside assistance. Some other features are listed here. I'm not going to detail all of them because I only have 5 minutes, but feel free to read them if you want. So how did we go about launching a system that is emergency system, has to save lives? Well, we did that by predicting the scale. We knew how many microservices our developers had created, so we knew we had 59 that we had to maintain, scale up, do things like that. Our SLAs, we wanted 90% of the transactions to take less than 3 seconds. That means if the vehicle's in a crash, we wanted them to be connected to a call center agent within 3 seconds of that crash. We also really wanted 99.99% uptime, very important. We didn't want somebody to crash and us not be there on the other end of the phone. So, So how do we do that? We used Datadog very heavily with observability. So we were able to create custom Java metrics. Our developers could create metrics on anything that they wanted to know about and send them up to Datadog for us to be able to consume, create monitors off of. We also use these metrics to connect to our horizontal pod autoscalers. So if some service started consuming a whole bunch of messages, we'd know, hey, that service is probably very important right now. We need to scale it up. We use infrastructure as code to create those monitors, so they all look very beautiful, and we can format them the way we want, have correct tagging on them, and those are linked up to Slack and PagerDuty. We also heavily use tracing. This way we can see the length of different calls that are going through. Somebody earlier was talking about microservices, so this is the way we can see if events are going through, which messages are consumed and published by which service, things like that. We also created a whole bunch of dashboards. This way, if something started to go wrong, we could see it before it was going to be a problem. So these different boxes would turn yellow or red. So it's just all we have to do is look up, say, hey, this box is red, that's probably a problem. So now let's talk about testing. Another very important thing about launching anything, we need to be able to test it. So since we have to do with vehicles, it takes a long time for vehicles to create it. So our suppliers were able to make these really cool dashboard sort of things. They're called test benches. They kind of look like airplanes with different toggles and stuff. So this way our QA team is able to press these buttons, trigger different things as if we had a real vehicle. This means we also didn't have to crash any cars to be able to test that functionality. Now these are cool, but we only had about 5 of them. And now that remote work is starting to be a thing, we need people to be able to test things just from their computers. So we created this, some sushi. It's a command line interface written in Go. This way developers are able to run the same sorts of things that a test bench can do in any environment they want, so QA, staging, or production. And it acts exactly like a test bench would for the most part. So they can run tests on a schedule, run them however they want, link them up to load tests, things like that. And you're probably wondering, why is that allowed? Well, VIN numbers actually mean things. So we're able to, any vehicle that's created with our little sushi thing called ICUDA, it's always going to be prefixed with IK, and that will never be a real VIN number. So this is how VINs are actually coded. So you can look at this and decode your VIN, see where it was built, different things like that, pretty cool. But because of that, we're able to exclude any test vehicles from databases or reporting. It's very useful. And we also were able to go to different factories as the first vehicles are being produced off the factory line. So different developers are able to go explore different factories, but highlighted where they are in red in North America. So that was pretty cool. And another very important thing of launching any system is being on call. So we created a whole bunch of escalation plans, different run books for, hey, we think when this alert goes off, this is how you're going to need to fix it, just so we were super prepared for when we launched. And how am I doing on time? Is that good? Is that 5 minutes? Cool. So yeah, this is how we were able to launch our platform very successfully, and knew like if this alert goes off, this is probably the problem. And because of that, we weren't able to have we didn't have any major outages when we launched this in the 2020 model year cars. Yeah, cool.
Thank you, Ashley. Great job.